Hi friends, welcome to Unit 3, Day 5 notes. This one talks about graphing rational functions. We're really going to dive into each of these different parts, talking about all of the steps, and then using a few of these graphs as an example. First, what we want to do, we want to follow kind of the steps here. We're going to really break apart each of these pieces and what each of these pieces represent as we dive in. So the first thing we want to do is we want to find the vertical asymptotes. You can either, remember the vertical asymptotes could also be holes, so you have to check that also. So for the vertical asymptotes here, for this particular one, remember we set the denominator equal to 0 and then solve. So for the vertical asymptotes, and I am going to kind of show each of these steps as we go through. Please do so as you're graphing as well. So for the vertical asymptotes, which you can just abbreviate VA, that's fine. Asymptotes. I just want practice spelling. So I'm going to set the denominator equal to 0 and then solve. Add 2, so I get x equals 2. So my vertical asymptote in this case is just x equals 2. Now, this is not the actual graph of this. By showing it on the graph, all I'm doing is showing it where the graph can't touch. So at the end, I'm actually going to go through and erase this. You will probably want to do the same. Or, in this case, show, I'm using a different color to show that this is not part of the graph. So the vertical asymptotes, for the asymptotes, I'm using a different color. When I actually graph it, I'll use a different color to show what's part of the graph and what's not. That's the vertical asymptotes. Find the horizontal or the oblique asymptotes and then label them on the graph. So what we want to do with the horizontal asymptotes is we follow one of three cases. Again, it depends on the degree of the numerator and the degree of the denominator. In this case, this is an example of one where you just have to look. You have to just know, oh, the degrees are the same in the numerator and the denominator. I just need to simplify the coefficients. In this case, the coefficients are y equals 1 over 1 or y equals 1. So the horizontal asymptote in this case is y equals 1. Again, doing that in blue on the graph, the horizontal asymptotes are used to construct the graph, but they are not part of the graph. Same with the vertical asymptotes. They're used to construct, but they're not part. Find the y-intercept by evaluating f of 0. So we're plugging in 0 in. So my y-intercept. So I plug in 0 for x. So I have f of 0 equals 0 plus 1 over 0 minus 2. So I'm going to simplify that. 0 plus 1 is 1. 0 minus 2 is negative 2. So it gives me negative 1/2. So my y-intercept, this is a part of the graph. This is on the graph. So when I plugged in 0 for x, I got negative 1/2 or negative 0.05 for y. This is on the graph itself. And that would be about right here. Find the x-intercepts by finding the zeros of the function. So now we're setting y equal to 0 and then solving. So if I set y equal to 0, think about it in the general sense. For this to happen, I essentially have to have whatever the numerator is set equal to 0. So in this case, when I set f of x equal to 0, my y value equal to 0, I'm just setting the numerator equal to 0, then solving. Why? Because 0 divided by any number is 0. So in this particular scenario, I have 0 equals x plus 1. So again, we ignore the denominator. Minus 1, minus 1. So I get x equals negative 1. So my x-intercept, in this case, I just have a singular x-intercept. Looks like it's going to be, negative 1 comma 0. Which is here. And that kind of falls in line with what I expect to happen on this graph. Knowing the general shape, it looks like I'm only going to cross through the x-axis once. This graph will not cross through. You could have some graphs where you do not have an x-intercept and you do not have a y-intercept. The parent function of the graph is a wonderful example. You will not have an x or a y-intercept. Determine whether the graph will cross its non-vertical asymptote y equals b or y equals mx plus b by solving for f of x equals b or f of x equals mx plus b. This is, in this particular scenario, this is usually when you have slant or you have oblique asymptotes, the way that you do this is you set, in this scenario, you set in this case, so our horizontal asymptote y equals 1, we're going to set 1. So we're going to call this cross the non-vertical asymptote. Question mark? So we're going to set, in this case it says y equals 1, we set 1 equal to, excuse me, x plus 1 over x minus 2. So now what I want to do is I want to solve for x. To do this, I need to multiply by x minus 2 on both sides. So I have x minus 2 equals x plus 1. So here, what happens if I subtract off x from both of these? I'm left with negative 2 equals 1. This is not a true statement, so this will not cross. So this is not going to cross your horizontal asymptote, because it's not a true statement. The last part, it says plot selected points as necessary within each portion of the domain to complete the sketch. I've got 2 points here, and what I mean by the domain, remember domain is x values, I've got 2 points here, but I don't have any points in this part. Again, these are just some things that you will know as you practice doing these. I need to get another point in these to kind of understand what's happening. Looking at this, negative 1 looks like a wonderful value to substitute or plug in. That'll give me another point here. So if I plug in negative 1, so f of negative 1 equals negative 1 plus 1 over negative 1 minus 2. So to simplify this, negative 1 plus 1 is 0. 0 over, oh, sorry, not negative 1, positive 1. It's like, that's going to come out to be a 0. We already found that, Mr. Brummond. Sorry. Hopefully you're using something that erases. 0 plus, there we go, 0 minus 2. I did it again. F of 1. 1, 1, 1. There we go. All right, 1 plus 1 is 2. 1 minus 2 is negative 1. So this comes out to be negative 2. So when I plug in 1, I get negative 2. So again, this on the graph in green, because it does exist. Negative 1, negative 2, right there. And then I kind of have enough points here on this side. I know it's going to get close to the asymptote, but it doesn't cross. So that's enough for me to know that it does something like this. And then like this. Do not cross your asymptotes. Do not cross your asymptotes. And then here, I need some other points for up here as well. So here, I'm going to have, let's do 1, 2, 3. So f of 3. That's going to be 3 plus 1 over 3 minus 2. 3 plus 1 is 4 over 1, which is 4. So this gives me the point 3, 4. 1, 2, 3. 1, 2, 3, 4. So this point exists. And then f of, let's do 4. That's a good one. So 4 plus 1 over 4 minus 2. That's 5 halves. 5 halves is 2.5. So if I put in 4, I have 2.5. 1, 2, 3, 4. 1, 2. So that is also a point on the graph, 4, 2.5. And then let's do 5. 5 plus 1 over 5 minus 2. So when I plug in 1 for x, what is my y value? So that's 6 thirds or 2. So this is going to be 5, 2, 2, 3, 4, 5, 2. So this also gives me 3 points. Notice that I'm getting 3 points. Ideally, that's how many points that you want for your graph whenever you're graphing these. You want at least 3. At least 3 so that you have enough to make the sketch. any less, and then it's really kind of hard to see what the shape of the graph is. When you get done graphing these, I would encourage you to then plug them into your graphing calculator to see how accurate you were. This is a good case. Many of you did not have situations where they crossed the non-vertical asymptote. So this is where a lot of you are going to struggle with seeing it. Going back into your graphing calculator and checking it to make sure that you did this part correct will help you ensure to know if it crosses or not. The other thing is that I use different color pens. So the green is the graph, and then the blue is the asymptotes. It's important to note these are two separate entities or beings. The asymptotes are not actually a part of this particular graph. If you were using a pencil, you would want to erase the asymptotes to show that they're not actually part of the graph. A lot of teachers will allow it because it's the dashed lines. As you move forward through math courses, the dashed lines could represent something else. So for this particular class, go ahead and erase if you have the same color and you're not telling me which one's which. Yeah, fantastic. I'll see you in the next video where we go over number 9.